Alright, today we're going to learn some more about matter. I know we already talked about solids, liquids, gases, and plasma a little bit, but I really want to focus on just solid, liquids, and gas, because that's going to be what's going to be really important in this class. So when we talk about a solid, it has a fixed volume and a fixed shape, and the particles are really, really close together. Alright, so those particles, they're only vibrating, they're not really moving. When we talk about a liquid, it has a fixed volume, but not shape. We know that if you put water in a glass, the water takes the shape of the container, of the glass. So that's basically what this is saying right here. And gas, it does not have a fixed volume or shape. So gas molecules are bouncing off each other, they're moving very quickly. So if we look here, this is a diagram of what a solid would look like. We can see that they are orderly and the particles are only vibrating back and forth. Our next diagram here, this is going to be a liquid. It has a fixed volume, but the particles are a little further apart and they're like sliding past each other. They have a little bit more movement than our solid particles do. Now if we go down to the end, this would represent gas. So you have particles all over the place, they're moving really fast. So we have gas, liquid, solid. Alright, in just a little while we're going to be talking about different properties. But first we have to talk about qualitative and quantitative measurements. So this is how we would describe our properties, using both qualitative and quantitative measurements. So first, a qualitative measurement is one that does not use any numbers. So it's not an exact amount, and it's kind of more like a description. So some examples I have are, this thing is heavy, or this thing feels smooth, or maybe this paper is thin, stuff like that. We have no numbers. When we talk about quantitative measurement, we're talking about a measurement that actually has numbers involved. So here we have 5 milliliters of water. That object weighs 8.7 grams, stuff like that. Or it is 6 centimeters long. That's what a quantitative measurement is. So qualitative, no numbers. Quantitative, it has numbers. An easy way to remember that is if you look at quantitative, it kind of sounds like quantity. So it's a quantity of something, how much of it. Alright, so now we're going to talk about physical properties and physical change. A physical property is a characteristic that can be observed or measured without changing the identity of the substance. So let's think about water here. Water has a specific melting point, has a specific freezing point, all that, and then we're talking about mass and density. Alright, so those are physical properties of a substance, like how much does that substance weigh and what is the density of that substance. If we talk about a physical change, it's a change that does not involve a change in the identity of the substance. So melting and freezing, if we're talking about water, we're talking about H2O, right? Whether H2O freezes, melts, becomes a gas, it is still the same type of molecules. It's still water. Just because we call it different things, just because we call it ice or we call it water vapor, it's still the same thing. It's still just water. So a change in state, which means we're going from one state to another, so that's solid, liquid, or gas, those are all physical changes. Another example of a physical change would be cutting something or breaking something. Just because we are altering it somehow, we're not changing what that substance actually is. Alright, so now we have to talk about chemical properties and chemical change. A chemical property is one that allows a substance to undergo a chemical change. So some examples of this are how reactive is a substance. So if you have a substance near fire, So reactive and flammable, if you have a substance near fire, is it going to light up in flames or is it not? That all depends on the substance it is. If you put fire near water, nothing's going to happen. That is a property of water. But if you put alcohol near water, near fire, that's going to go up in flames. So a chemical change now is a change. Okay, sorry. The chemical change changes the identity of the substance. So, for example, if we're burning something, so if we have paper and we light it on fire, it is no longer paper. Now it's ashes. It has completely changed what that was. So cooking, so if thinking back to biology, if you cook something, it changes the proteins. So it's actually becoming something else, all right? And then reacting with air or water, when we think of iron, if we put it out in water and then allow that water to be in air, we form rust. So those are all examples of chemical changes. All right, so in order to figure out if a chemical change happens, we can look for these 4 things. Your first thing is, was a gas produced? So the way that we know if a gas was produced in the chemical change, if we see bubbles or if we smell a change in odor. Another way to see if a precipitate forms. The word precipitate just means a solid that falls out of solution. So if you mix 2 clear liquids together, so 2 different types of solutions, and then it became cloudy or you saw something solid at the bottom, that would be a precipitate. Number 3 is energy released or absorbed. So in order for us to figure out if energy was released or absorbed, you would have to see if there was a change in temperature. So if you were holding something and maybe it got really cold in your hand or got really hot in your hand, that's how we know if energy was released or absorbed, and then a giving off light. Light's a different type of energy, and we're going to talk about that later. And then your last thing is a change in color. If you mix 2 clear liquids together and they turn yellow, that means that a chemical reaction occurred, and that is a chemical change. Okay. Let's talk a little bit about chemical reactions. When 2 reactants come together or form a new, they either come together or apart to form a new product. So this usually happens with the change of energy. And we're going to talk about energy later on in the course, but just know that when a chemical reaction does occur, usually energy is either absorbed or emitted, and we will just take it from there for now. All right, so an example of this is iron plus sulfide forms iron 2 sulfide. All right, so we have iron and sulfide, which goes to iron sulfide. If you look on the left of this arrow, these are called our reactants. If you go on the right of this arrow, those are called our products. So anything to the left is a reactant, anything to the right is a product. All right, if you're an academic chemistry student, you can turn the video off now. If you are an honors student, keep listening for a little while. All right, so this is for honors students only. We have to talk about intensive and extensive properties. So an intensive property is a property of the substance that does not depend on the amount. So no matter how much of that substance we have, they're still going to have this property. So density, we already talked about density, how that does not change with how much you have. That is specific for the substance and does not matter on the amount. The ability to conduct electricity. If we think about a metal wire, if your wire is this big versus this big, it doesn't matter. It's still going to conduct electricity. So that's an example of an intensive property. Now if we think about an extensive property, it's a property that depends on the amount. So some examples are volume, mass, and energy. If you have more of a substance, if you have more matter, it is obviously going to have a higher mass. It's going to take up more space, so it will have more volume. And then energy, the more of it you have, the more energy that's contained in that specific matter. All right, that's all for this. So hopefully, honors, you're still listening. You had to know all of that. Academic, you did not need to know about intensive or extensive properties.